but not least, this is one of my favorite parts. A equals 5, B equals A equals 10, console log B prints out
5.
Who said 10? Here's why. And we know this. We don't know why, but we learned this. First day of JavaScript. The variables that we create actually exist inside our computer memory. That's where variables go. That's why we need computer memory. Okay? If you haven't made that connection yet, then congratulations. Now you know why we need computer memory. Right? Like, we're going to make sense of everything that's in your, by the time you're done this course, all the stuff that's in your computer is going to make sense. And this is RAM, not hard drive. Hard drive is long term, RAM is short term while the program is running. So while your program is running, a variable is created, A, and the value is 5. And then the next line says B equals A. Okay. New variable, B. Whatever the value of A was, that's also the value of B. It's not this. No. It's this. And so when we're changing A, right? This makes sense? I'm not also changing B, I'm changing the value that's in A. I made a copy. I make a copy. And this sort of concept, this is called pass by value, or like, we use it by value. We pass it by a value. We create a new copy. When I change A, I destroyed 5. You saw me erase it. I destroyed it. And I created I input a new value. This works for primitives. This is a defining feature of primitive data types. And we haven't fully discussed what a primitive data type is, but let me tell you really quick. Things that we know are primitive data types. There's others, but these are the main ones that you're going to be using. So, if I were to do the same thing with a string, you would get the same result. And if you don't believe me, we can just try it out. Okay, I changed A, but that doesn't change B. Just because I changed A, that doesn't change B. Strings are the same. So numbers, booleans, and strings, they all do this type of thing. Arrays are different. This is how arrays work. So let's say, let's make up some new variable names. C. and D. So if I did the same thing with an array, C equals, right? This, 1, 2, 3. Let D equals C, C, 0 equals high, console log D.
What?
Because they are referring to the array by reference. So when I say D is equal to C, I'm not creating a copy of this array. It is simply saying that spot in memory that you stored that array in, I am also going to refer to that same spot in memory. So that array lives in memory, and the variables are just pointers to that spot in memory. They're just pointing at it. They don't actually contain the value of it. They're pointing to it. So there's only one copy of that array here, in this case, the way we set it up here. There's only one copy. C and D both point to that one copy. That's like saying, this is your Mac, this is Saria's computer. Both of those things are true, right? And they're both referring to the same thing, right? So that's this. They're both the same thing. They're both referring to the same thing. So I can say, I think I'm going to try this. I'm sorry, I don't really know how to spell your name. And so, is that incorrect?
Yeah, it's okay.
Okay. And oh, sorry. Right? Your computer is your Mac, and your Mac is this array. And if I change this array, it's changed. If I install something on that computer, it's on both of these because these are just referring. They're just different words for your same computer. But if I did this with a number, a Boolean, or a string, it actually creates a new computer.
So as long as it's not primitive.
As long as it's not a primitive.
Okay.
Yeah. As long as it's not a primitive. So if I do that with any other type of any other data type, it refers to the same thing. Or any other data type, it's something different. Primitive data, non-primitive data types refer to the same thing. And so that's really important to understand, because if you go about changing arrays in places, you need to understand that anything else pointing to that array could also be impacted. You will see this, okay? This might be like really confusing right now, but once you start using them, this little bit of information will come back to haunt you a little bit. Like, not haunt you, but if you didn't know it, you would never understand why is my array not what I expect it to be. And the answer is often, it's because you changed it somewhere else and you didn't realize the impact of that change. We don't have that problem with these. And so the types of problems that you would encounter with these primitive data, or with arrays, you wouldn't have encountered with these primitive data types. Okay, and as you start doing some exercises, you will see this happen. Okay, you will encounter this. So my recommendation, do not change an array while you are looping over it. Do not change an array, do not modify an array while you are in the process of looping over it. You will get unexpected results. Okay? Most of the time, unless you really know what you're doing.
Are you
It's
saying
simply
do
a
not,
recommendation.
Are you saying do not put arrays in loops?
No, I'm not saying that. I'm saying if you're looping over an array and you're doing something with the values of that array, it's okay to modify it. You don't want to change the length necessarily, because that loop is oftentimes running based on the length. And if you start changing the length, your loop is going to start changing on you.
Okay.
Right? So you can modify the individual elements inside of it, but just be careful, it gets dangerous when you start playing with the length.
Okay.
Because if that length is becoming variable, suddenly, you go into the loop with this idea, oh, this loop will run X times based on the length of the array. Oh, but now inside the loop, you're changing that length. And so like, whoa, that might not work out in your best interest. We're gonna stay on arrays for 2 days. So we're coming back to arrays tomorrow. But tomorrow I'm going to introduce you to a bunch of new stuff, and that's going to coincide with a lot of the stuff we talked about on Friday, which is functional expressions, inline functional expressions, and callbacks. So we're going to I'm going to introduce to you the reason why we would ever want to do that crazy thing where we pass a function into a function, and it'll make sense to all. So today, for arrays, I have some practice. So this is, okay, so this is, this isn't pass by reference. What I mean by pass by reference really is, it comes down to functions. And this is where pass by reference matters. So this is where this is where it comes from, pass by reference. If I pass my array in to here, my function, and I make a change to that array inside the function, it reflects outside this function. This would not happen with a number, for example. So watch. So I pass the array in as a parameter. So the reference, I'm passing it by reference, gets stored in here. It makes a change to that array that's in memory and changes this to 10. And then when I print it out, that's what I would get. But if I did this with a number, and then I said, that. When I pass it into the function 5, it makes a copy of 5. And so R, even though I'm making it now 10, it's still 5. So this is passed by value. This is by value. This is by reference. I'm passing in a reference to the array versus I'm passing in a value directly. That's where that concept comes from. I'll find out the actual concept of how this exists within memory, so I can give you that name.
Is that because you use count and not length?
Irrelevant. That has no impact on it. Whether or not you use const or let, it's still the same result. Yeah. So a couple of pretty crazy things that we learned today. The nice thing is, for the most part, 10% So 90%, most of the hardest things that we did today is going to only be about 10% of the stuff that you ever do. Very limited amount. Of all the things that we did today, the hardest stuff you won't see very often. It's usually the easiest stuff that you'll see. Making an array, looping over an array, adding stuff to an array, getting the value from an array. That's mostly what you'll do. Occasionally, this will rear its ugly head. Nested loops will rear its ugly head. Pretty infrequently.
Is it because they're difficult, right?
No, it's because there's not a lot of use cases for it. They're very specialized. Like, I can come up with examples coming out of my butt for all this simple stuff. Because you do it all the time. But the other stuff, it's really hard to come up with a use case for it. And so it's really hard to come up with examples that are meaningful. Because we just don't do it that often. Maybe if you're getting into like very specialized territory, but I was never in there. And as a junior developer, you're not going to be there either. Okay. Let's take a break. Come back. I'll answer any questions. We'll go over the exercise, and then you'll have an hour to do it. You can come ask me a question.